All of this functionality is the part of the analytics feature which differentiates us from several of the other vendors. The other thing that I wanted to quickly talk about is service chaining, and the way we do service chaining, why it makes it a very multi-vendor kind of a fashion. So in the logical world, you basically define a policy. You say that, let's say I have two virtual networks, red and green, and I want to service chain them with, let's say, two instances, a firewall and a DPI, right? So in the actual physical, policy enforcement phase, what happens is there are all these, VRFs that are created within the vRouter on all the hosts. So for simplicity, I've assumed that all of these are running on different hosts, but they can run in any combination. So if you look at the way we do service chaining, if the red virtual network R1 is trying to talk to the green virtual network G1, it sends out a packet, and once it reaches the vRouter looks up this table and says, okay, if I need to send to G1, my next hop is going to be server S2 with the label L3. So IP Fabric forwards it to server S2, and every interface has a label, and so it gets forwarded to that label. Again, when packet comes out on the other side, it looks up, destination is still G1, my next hop is going to be server S3 with label L5, and that's how it ends up at server S3 on the left interface of the service. So now if you look at the way we have done service chaining here, it is, we have not modified anything in the service itself. There is no unique packet that is going inside this. We strip off everything when we send the traffic. So we do service chaining using routing, and that is what makes it a very multi-vendor in nature, because if you don't like this from a particular vendor, you can yank it out, put something in its place, and that should work. So that's one thing. The other thing is that these services can also scale out horizontally. So you can have multiple instances of those, and that's when vRouter ECMP load balancing also kind of kicks in, right? So, yes.
Oh, so you mentioned to Larry, so if you have physical, this is for virtual.
This is for virtual
instances of devices.
Yes.
So if you have physical IPS or whatever, you have that coming up?
Let me actually answer that. So that is something that we can do manually. What we are doing is we are automating that using netconf to the MX. The way we do physical service chaining is, imagine this was a physical firewall, and imagine this being, instead of a vRouter, it's an MX. So we just stick it to the MX, and that's the only difference. Everything else, the constructs, whatever we do within a service chain, exactly remains the same. So this vRouter is replaced with an MX, and that's how you can seamlessly do service chaining.
So you can do it with some virtual
devices, exactly.
Some physical devices going up to the MX, back down.
Yeah, they're probably just hardware-based VTEPs that I'm assuming, right, on the MX?
So MX, yeah, you create these VRFs. Exactly as you do in case of a virtual instance, you create these VRFs, and that's how it actually goes from one interface to the other. So just if you replace this thing with an MX, where you tie the physical instance, that's how you actually can do it.
And going back to what you said, because of the way that you service chain is based on route,
right? Which
is why physical theoretically is no different than virtual.
That's right. That's exactly it.
So you're just changing a route. If I put another firewall in, or some type of inspection that it needs to go through on the way out or in, I can manipulate with that with the service chain, because it's just a route. You're not tagging traffic or anything.
That's right. That's absolutely right. Okay, so let's move on to use case.